Hi, Naval this side. So in this video we are going to start with exploring the core data concept. Let us begin with the core data concept. So you can open this, and there are maybe few units you can see, and what will be the learning objective. So once you complete this module, you will be familiar with and you will be learning like, hey, what are the common data formats, what are the options for storing your data in your files, what are your options in storing the data in the databases, and what is the relational databases obviously, and what is OLTP, that is a transactional data, and you will know about what is OLAP, that is your online analytics data processing. Also OLTP, OLAP, we are going to see that. So let us begin with the first one, that is the core data concept. In that, let us begin with the identifying the common data format. So you can just click on the introduction part and you can just read out what is the introduction here. So over the last few decades, the amount of data generating has significantly increased. So the now data is generating with the help of machines, systems, applications, or any devices like IoT devices and anything. So now data is like a air. I call data as like a air, or you can call data is everywhere, and it is in humongous amount of data is generating every second. Okay, now let us see how much of data it is generating per second. So what is happening every 60 seconds online? So you can see in 1 minute, approximately in 60 seconds, there are almost 500 of videos are getting uploaded on YouTube, and there are almost 65,000 pictures are uploading on Instagram, and there are almost 1300 plus posts on LinkedIn. And if you see the Facebook likes, it crosses around 3 lakhs. Pinterest or pins around 10,000, TikTok views, Snapchats. So this is all related to social media. I'm not talking about anything related to your IoT sensors and your CRMs. All those are additional again. So just imagine how much humongous data is generating every 60 seconds online. So you can read this. It is simple. Like, now data is easier to collect and cheaper to store, making it accessible to nearly every business. So data solutions include software technologies and platform that can help facilitate the collection, analysis, and the storage of valuable information. So what all these people, all these organizations, all these big tech giant companies are doing with their data, so they are using their data to make their business more profitable. So from their business, they want to grow their business, they want to grow their profits by the help of their data. So with this data, they are going to lead the market. So you can see, like, we have so many cheap storage devices, like how you can store the device. So if you go back to 20-30 years back, there we used to use a ploffy or a CDs to store the data, but now there are so many alternate devices where you can store the data. Now you can just store the data in the cloud, that too very cheap, in very cheap format. For example, you can spend only few pennies to store the huge amount of data. For example, if you take an Azure Blob Storage or Azure Data Lake Gen 2, it is taking only few cents to store the, like, hundreds of GBs of data. So that is so simple. So let us go proceed further. In the first point, it is about the data formats. So we have discussed this, so let me discuss again. So the data is generating huge amount now, but let us see what exactly the formats are, or what are the forms of data. So basically there are three major forms of data generating. First is your structured data, second is your semi-structured data, third is your unstructured data. You can see it. So you should be very clear if you are entering into the data world, like what are these three forms. So first is your structured data. It is simple. Structured data will have a highly organized data. For example, The best example I can give you for the structured data is your table. So the table has rows and columns. The table has a structured schema. It has a fixed columns and it has a fixed rows. You can read this table. Most of the time the structured data is in the tabular format. The examples can be your database table, it can be your Excel sheet, any of that. So that is a structured data. But if you have a structured data, there is not a big issue on that, because you can do analysis on top of this, you can do some aggregations on top of that, you can calculate sum, you can calculate minimum, maximum, all that by using an structured data. But the problem comes when your data is a semi-structured data. Like, it is not highly organized, it is somewhat organized. And the best examples for semi-structured data I can give is your JSON file, your XML file, your HTML file. So what are JSON files? So JSON files are like one of the semi-structured data. JSON means that JavaScript object notations, that stands for JSON, and the data will be stored in this format. You can see this is like a key value pair inside a dictionary. So this, you cannot do the aggregations on top of this. You cannot find out, hey, can you please tell me the maximum number, what is the maximum sales, what is the minimum sales, what is the sum of the sales. I cannot run that because it is a semi-structured data. So this example is best for a semi-structured data. So here also we can convert a semi-structured data to a structured data in a tabular format. But the most challenging part is your unstructured data. So unstructured data is not at all organized. You can take the best examples of an unstructured data like your documents, your audio files, video files, your images, your PDFs, and someone is writing a letter and a handwritten. All these are considered as an unstructured data. So the challenge here is how to solve this unstructured data to a structured data and pull out some meaningful information from that. That becomes very challenging. And when it comes to data store, most of the organization typically store their data into various forms like structured, semi-structured, and unstructured formats. In these two broad types or broad categories, one is your file store, second is your databases. So what are these two? We are going to see in detail in the next point. Storage. You can just click on continue. You will be getting into the exploring the file storage. So you can read these, like there are so many files formats, like you have an JSON file, maybe a CSV file, that is a delimited text files. It can be both CSV or a TSV. So CSVs are nothing but comma separated values, TSVs are nothing but a tab separated values. So if I just show you the difference between TSV and CSV, so if I look at a notepad, a simple notepad, and if I start writing, hey, my ID, and press a tab, this is my name, this is my age, and this is the location. Okay, so ID is 1, name is suppose Naval, I'm age 31, location India. Okay, so this is your tab separated. The fields are separated by the tabs. And similarly, if I write ID comma name comma age comma location, and if I say 1 comma name comma age comma India, this can become your CSV. So this is your CSV, this is your TSV. So the difference between CSV and TSV are nothing but a comma separated and a tab separated values. So these are nothing but your CSVs and TSVs. So let me explain you about the file storage. So you can store all these data files in your personal computer, in your hard disk, in your USB, in your flash disk, any of this. And if you have a huge amount of data, then you can use this to the cloud also. So you can store that in the cloud also. Okay, so in the cloud you can store any type of data, like it can be a structure, it can be a semi-structure, it can be unstructured, similar to like how we store in our PCs. Like in my PC I can store a table, I can store a JSON file, I can store a a movie, images, anything, all can be stored. Similar to that, we can store in a cloud. So this is a best example of the JSON file. We will decode that later on. You can see this is your first field. Inside that we have again a dictionary which is showing the customers like first name, last name, and the contact. In contact again there is a nested, this is so much nested JSON. So this is actually one record. You can see this is one record. So inside a customer column there is first record. Hey, this is the first record which is having first name, last name, and contact. In contact they have the two types of addresses. One is their home address, one is their email address. So you can see like home phone number and the email. So this is the first record. This is highly nested JSON file, and you can see the semi-structured example like an XML. XML is an extensible markup language. So uh, this looks like a human readable code, but you cannot run some aggregations from this. Then the next data type or next format is your binary large object. So that is, it is abbreviated as blob. BL for binary large object, that is object. Okay, so sorry, object, binary large object, that is called as a blob. So all the files like internally get stored in this binary formats, that is all ones and zeros, but the above formats are all the human readable formats. So we need to convert this binary to some codes. So we are going to see in detail like what is the ASCII values and what are Unicodes in detail. By the help of this ASCII and Unicodes, your all data will be stored in this blobs. So when you are mostly working on this data field, we will come across this word like a blob. So we are using or we are storing all our data inside this blob only. So if you are like if you want to see like how to open an storage account on an Azure and how to like use this blob storage, so I have made a video on this, so kindly watch that on that. And now like everyone, they have a huge amount of data. Now everyone is working on to optimize that data. So you already have the data with you, huge amount of data. If you have the data in GBs, terabytes, even petabytes of data also. But if you want to make your data more human readable, but that should be more optimized, then there are some optimized file formats. These are also called as big data file formats also. So they have Avro. So Avro is a row based format, and it was created by an Apache. So what is Apache? Apache is nothing but an Americans non-profit organization company, so they don't make any profit from that. So it is completely open source. They have more than 350 plus projects on Apache. So when we start about the big data, we are going to see about what is Hadoop, what is Spark in detail. These two are also the Apache projects only. So this Avro, like Avro is also one kind of format. So this Avro or ORC or a Parquet, this is pronounced as a Parquet or a Parquet. Okay, but it is mostly pronounced as Parquet. T is silent here. So these three are the optimized file formats, and we will see that in a real time in our coming sessions. But just remember, Avro is a row based format, and ORC is a row columnar format, and Parquet is a columnar data format. So if you want to know what do you mean by row based and the column based, so let me explain you in a simple or a layman's language. So if I'm talking about the row based, your data is always in the row, just like what we can see in our sheet. Yeah, let me open this. And yeah, now if I have ID here and name here and age and location, so suppose ID 1, and let me take see Sachin here, and his age maybe 40 or 50, and his location is India. Okay, let me take second, suppose Virat, and his age is maybe 35 or something, I don't know. India. Okay, so this example can be called as a row based because you are getting your data in this way. Hey, when the third person comes, I'll just adding here. But what is column based? Your Parquet file stores the data in a columnar format. What do you mean by columnar format? So what does that do? It will add the fields in this way: ID, name, and age, and location here, and your ID will be 1 year, and A is Sachin here. Okay, so here we get Sachin, and age is around 50, and it is India. So this is your columnar format. Your data keeps on appending in this columns like this, and row based your data keeps on adding like this. So this can be the best example of Parquet, and this can be the best example of your Avro and ORC. So these are optimized data formats, Avro and ORC. Okay, so we are going to see in detail about these data formats, but just now you can just remember this is the way the optimized file format works. Okay, so you can just read out the detail about this. Let me explore more on the databases. So when it comes to the databases, so databases is defined as a central system in which the data can be stored and queried. So it is one of the central repository where you store all your data there. Okay, there are two types of databases. One is your relational databases, second is your non-relational databases. So what do you mean by relational databases? So by this image you can clearly understand that, hey, relational databases are nothing but we have a tables, and all that tables are connected to each other, or they have some relationship between each other. For example, if you look at this customer tables, so is having an ID 1, is having some mail address, and your address. So if you want to know, hey, who's that customer 1, can you please tell me the details of that customer 1? Yeah, I can just see the ID here and look at this here. So he is customer 1, he has ordered order number 100,000, and he has ordered at this date. Hey, what is 1000? Can you tell me what does that 1000 item means? Okay, come to next table. So 1000 is nothing but it is item number 1, and it is product 123, and it is quantity 1. Hey, can you tell me what is product 123? I don't know what is 123. Okay, come to the next table that is having a relationship here. So this is showing me 123. Hey, it is a hammer. Okay, the price is 2.99. So this is how your relational databases works. So it works on the primary key, foreign key, all those things. We are already seeing this. So if you want to communicate with these tables, we need to use a language that is called as a SQL language, that is called as a structured query language. Now coming to the second point on databases, that is a non-relational databases, and as a name itself indicates, non-relational, so it do not have any relation between the tables, between the databases. So we call it as a non-relational databases, or most of the time it is referred as a NoSQL databases also. So if it supports the relational database, we call it as a SQL. If it doesn't support a relational database, then we call it as a NoSQL databases. So there are actually four types of like things where you can like store or use a non-relational databases. First is your key value database. Your data will be stored in key value like this, and second is a document database. So it is also in a key and document, you can see this. And the third is your column family database. So just now I have explained you, it goes in a column format like this, columnar. So that is a column based column family database. And the third is your graph database. So your database is stores in the graph. So this works like your nodes and the relationship. Suppose if you look at this Ben, so Ben, who the Ben reports to Sue, and who and she is working in the hardware, and he is also working in this hardware. So with the help of this graph, we can find out the data. So just to have a quick recap, relational databases, non-relational databases. To use relational databases, we use a SQL language, and for non-relational databases we use a NoSQL databases. There are four types here: key value, document database, for column databases, and your graph databases. Let us see the next unit, that is exploring the transactional data processing. Yeah. So we are looking into the transactional data processing. Whenever you call about this transaction, you should remember the one keyword, that is OLTP. So the abbreviated form of this OLTP is nothing but online transactional processing. So as the name itself indicates, transactional. So whatever transactions you are doing, whatever events you are doing, each and every time if you do some transaction, let me take an example of the payment system. For each and every time you are doing one payment, so that are stored in this OLTP. So you can see the person who is doing some transaction, so that transaction is stored in this database, that is called as an OLTP, that is also called as online transactional processing. Yeah, let me read this. So a transactional data processing system is what most people consider the primary function of business computing. A transactional system records transaction that encapsulates specific events that the organization wants to track. A transaction would be of financial, such as the movement of money between the accounts in the bank system, or it may be a part of the retail system. So if you take any financial system that are working on any transaction between the monies, between the like amount money between the accounts, or it may be any retail system, if you take an example of DMart, if you take an example of Amazon, if they are getting millions of orders every day, so these all are considered as an transactional data. So because it is getting the data generating every second, that is and a high volume, it is continuously coming at a high velocity also. So uh, transactional systems are often high volume, sometimes handling many millions of transactions in a single day. So the data processed being processed as to be accessible very quickly. So the work performed by these transactional systems are often referred as OLTP, that is online transactional processing. These OLTP solutions rely on the database systems in which the data storage is optimized. It is optimized for both read and write operations in order to support the transactional workloads in which, so if you are using an OLTP, so this data records are, it can be created a new record, it can be retrieved. If you have already a data, it can be retrieved, it can be updated, and it can be deleted. So you can do CURD operations on this. So what do you mean by CURD? That is create, retrieve, update, and delete. So if you have the existing data, you can retrieve something from that, you can update in that, you can delete also, and if you want you can create also. This is about the CURD operations, and these operations are applied transactionally in the way to ensure the integrity of the data stored in the database. To accomplish this, like OLTP system enforce transaction that supports so-called the asset semantics. So if you are working on this, like if you want to create, if you want to retrieve some data, if you want to update, while doing all this, it should have a strong support on this asset properties. So now what do you mean by asset properties? I'll explain you in a simple layman's language. Just so let me explain you a simple layman's language on what is asset transaction. So asset transaction stands for you can see A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. So this all becomes your abbreviated form of ACID. ACID. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. So let me explain you a simple example like all about this ACID. We will see in detail about what is atomicity, consistency, isolation and durability. So let us imagine that, hey, I have an bank account in any bank. So bank account, let me take, I have an account in my HDFC. Now the in HDFC bank account, the minimum balance should be suppose 10,000. Okay, I have, and minimum balance should be 10,000 there. Now I have suppose 25,000 in my bank account, 25,000 rupees, and I want to transfer it to one of my friend. Okay, I want to transfer it to one of my friend. Now let us imagine I have transferred 10,000 rupees to him or her. Now once I transfer it, just imagine if the amount is not being debited from my account. For example, it is not debited immediately, it is taking some time, whereas your friend's account is not being added to this 10,000 immediately, it is also taking some time. So this may lead up to like a like inconsistent state, or it may give you a wrong assumption like, hey, I, if it is not detected, what I feel that, hey, I already have 25,000 in my account, but that is not true because you have already sent 10,000 from your account. So now it should show me 15,000. So this is what your system leaves in an inconsistent way. And the second thing is like, if I have transferred 10,000 and, or a simple example, let me give you a simple example. I am withdrawing a money from my ATM. I am withdrawing the money from that ATM. So let us imagine I am withdrawing 10,000 rupees. 10,000 rupees. Now what happens for this? So if you are withdrawing and your ATM machine has some problem in between, it has some problem, so it leaves your system inconsistent way. So what will happen? Either you get complete 10,000 on your hand, or you may not get the amount, it will be inside your ATM machine. It is not like that money goes somewhere in between, it will not happen that in any ways. But what can happen, you will not get a money, but that 10,000 will be debited from your account. So if that happens, then you have to contact your bank and go to raise a complaint, and then you might get your amount back. So this is what your system lives in an inconsistent way. So this is all about the ACID transaction, like A, atomicity, consistency and isolation, durability. So just imagine that ATM machine, I am withdrawing the money, and if it doesn't, your money doesn't comes in your hand, and if your account get debited, so it all becomes a big mess up with your account. So we are going to see in detail about all these four terminologies, but just try to understand that ACID transaction means something about, you can assume something about your account or your ATM account. Let us see the last unit, that is your transactional data processing. Analytic data processing. Now we have completed the transactional. So let me show it here. So when you are generating the data, that is your transaction. So all this is called as an OLTP, that is online transaction processing. Once your data is been loaded into your databases, now the data is stored in your database by using this transactions. Now we need to use this data for some, pull out some key insights and to do some or pull out some meaningful information from this data. Then we are using a different processing, that is OLAP, that is called as online analytic processing. So we are doing some analytics on top of your data, you can see this. So when it comes to OLTP, just let me show you one thing here. So this offers both read and write operations. You can read and you can also write in the OLTP. But when you are talking about analytics data processing, the most of the time this is only read only, because we are just reading the data from that. We are not manipulating any data in your database. We are not trying to change your data, because the data is generated already. We are just reading that data. So that is your read only in analytic processing. So you can see this beautiful architecture here. So you are getting a data from maybe your file store, which sits in your uh, cloud or in your PC, or this is your database. The data is stored by using a transactional, and we use that into a system called as a data warehousing. So once your data is in your data warehousing, then we do some online analytic processing on top of this data, and we create a cube. So this cube and these all things are called as analytic processing, that is called as OLAP, that is online analytic processing. And with the help of this cubes, we will see in detail, with the help of this model. Now in OLAP, most of the time we create a model like a star schema, snowflake schema, single table, multiple table, fact table, dim tables. Everything is done in this, like what are majors, what is dimension tables. And once you create that tables, we call this as a cube, and we connect this to our reporting tools, like creating a visuals, building a reports, building a dashboards on top of this. So this is how your final, you can call this an ETL pipeline, like we are extracting the data, doing some transformation, and then loading it into our Power BI or maybe any BI tool. So this is about the OLAP. You can just read out this. And finally we have a knowledge check. So let us do this. Now I want your participation. So how is data in the relational table organized? So if you are talking about the relational databases, so your relational database means your table. So exactly, so in a relational databases or relational table, we have rows and columns. So very simple. Which of the following is an unstructured data? So we have seen in detail what is unstructured data. So audio files, video files is an unstructured data. So a table with the column employee ID, employee name, employee designation is your structured one. A relational database is also an structured one. So the answer for unstructured is audio and video. Now what is a data warehouse? So data warehouse, it is a non-relational database optimized for read and write operation, or a relational database is optimized for only read operations, or a storage location for unstructured data files. So for unstructured data files, we are using a blob storage. For data warehousing, we use only relational databases. That is very important. So for non-relational, we do not use a data warehouse, because data warehouse can store only a structured one or a relational databases one. So that is the correct option. So let us check. Don't worry if the answer is wrong, you can go back and you can do that again. So you can see all are correct. So you get one small batch also, like you have completed this, and you can see what you have learned from this. So now we can go and review the next learning path. So the next path is, so we have completed this, like exploring the core data concepts. Now we can go on to see what is exploring the data roles and services. I hope you enjoyed this video, guys. So if you like it, please subscribe to my channel. Thanks for watching again. Keep learning.